Hello, everyone. Thanks for joining another Cyber Skyline Live. I'm Franz Payer with Cyber Skyline, and I'm here to help you learn cybersecurity. We run these episodes for you, so please stick to the end and let us know what topics you want to cover next. And this week's topic is writing code for log analysis. So sit back and relax. I've got some tea here. Everyone just enjoy these slides. I'm going to have a demo at the end. We're going to go look at some code. And please ask any questions that you have along the way as we walk through today's show. I will try to answer them. If you're watching this as a post recording, and ask them in the comment section. We'll go back and we'll answer any questions in the comment section. But without further ado, let's go and take a look at coding for log analysis. All right. So the first question that you're probably asking yourself, if you're completely beginner to this, is what is a log and why do we even care, right? So the question for what is that a log it's just a data record, and they describe activity that occurred on a computer or a computer network. Basically, it's a history of everything that happened. Now, there are often multiple different applications and multiple different types of logs that make up a corporate environment. As an example, you might have some programs that allow people to log in remotely. You might have an application that records all of the login attempts to a computer. You might also have a website, and that website might have a bunch of different requests that people are making to it. And the software that handles remote login or remote desktop is different from the software that handles the website. And so there's two different pieces of software that have their own individual logs. And all of those logs collectively are what an organization can use to identify what is happening on their computer network. When something goes wrong, they can figure out what happened. Another example of a log might be an error made in an application. And so what you can see here with this graphical representation is an example of a logging that occurs on a website. You have people who have a browser client who are accessing your web server. Every time someone makes a request, if you want to see what is happening historically, you want to do some analytics, you want to see if maybe we got attacked, you will want to log that information. And so the IT team will log the data that is log all of those requests. You'll get this data in a log file, and it might look something like this on the right side. This is an access log from a web server. So not all logs are the same. Logs are dependent on the application that created them. Some are text, some are binary files that are more heavily compressed, a little bit more easy for a computer to read through efficiently. But they all serve a different function, a different purpose, and just logging in one location is not sufficient to make your organization secure. You actually have to log everywhere where you're collecting, where you're having like activity, right? Anytime that someone is accessing any of your resources, and that's an important thing, like login or maybe accessing sensitive records, you want to have a log of that, because if you don't have a log of that, that can cause some problems. And so this goes into why our logs are important. I mentioned earlier that security teams are going to be using these logs. Basically, it's imagine this as you're working security at a bank and you don't put up any security cameras. You don't have any record of what is going on in your physical space. So logs are the digital equivalent of like a security camera, although they're a little bit more useful because they're more structured. But the idea is that if you are not recording your security camera footage, and if you're not logging your computer activity, the end result is the same. If a breach occurs, you might not even notice that it occurred. And after you notice it occurred, you might not even know what happened, right? You can't see the series of events that occurred prior to the final culmination of, hey, you got robbed, right? Or in the case of your computer network, your database got breached and all the records were stolen. They have credit card information. You might be able to tell that that information was stolen or manipulated, but you might not know how it happened. You might not know how they got in. And that's why logging is so important. So in theory, if you have an organization that has an effective logging policy, they're logging everywhere, you can see those steps. It allows you to identify when you've been breached earlier. Maybe you can catch them when they're coming in through the door, right? Instead of when they're stealing your cash. The digital equivalent of this is you catch them when they breach a device before they get into your database, right? There's multiple steps involved with compromising a corporate environment. And if you can catch them on step one, then you can respond to it much more quickly. You can reduce the impact of the damage that they do, and you actually know what's happening, right? That's the big thing, because it's entirely possible that with a poor logging posture, someone breaks in and steals all your records. And the only way that you know that this happened is you start seeing your customers' records on the internet, in the dark web, and you had no idea that they were even there on your network to begin with. And that's why it's so important. And so you can see here, this is a log of a web server. And this line here is maybe an indication that you've been hacked. It's an actual exploit that is happening on your network. And if you don't even record this information, and someone is running an exploit that gives them code execution on your servers, you want to know that. And these logs might be a good way for you to find out that someone has code execution on your servers. Now, there's a lot of false positives, and you might be coming through a lot of these false flags, right? But if you don't even log any of it to begin with, then you don't have a starting point. So that's why logs are important. The second question becomes, how do we actually analyze these logs? How do we make sense of this data? How do we find useful information from these logs? And so I covered this in a previous episode, but I'll do a little bit of a recap. There's a lot of command line tools. If you're using Kali Linux or some other Linux distro, you can use the command line tools to parse log files and get some pretty easy, important information. And so here's a pretty big table that will kind of outline some useful tools. We've got cut, sort, unique, grep, word count, that's WC, and awk. These are all very, very common tools that will help you with parse through logs on the Linux command line. A quick overview of what these do. So cut specifically allows you to get a column from a log file. And so if we go back to the previous slide, you can see here that a lot of this information is separated by spaces. So you have an IP address here, and then you have a space, and then a dash, a space, and the dash, and a space, and then here's a timestamp, space, and then here's some the request that was made, the HTTP request that was made, space. This is a status code, space, and then this is the size in bytes that the request, how big of a request this was. So there's a lot of spaces here. You can use cut to specifically say, hey, let me grab this column because I want to weed out all this other data. If you're looking through a CSV file, a comma separated value file, cut can be a very helpful tool to help you parse through that file if you only want one column of data. Sort will basically do a sort, pretty self-explanatory. If you have a bunch of different lines of data, it will do, you can do an alphabetic sort, you can do a numeric sort, but it will sort all the data in a nice fashion. Unique is unique. Basically, if you have duplicates of the same data, it will eliminate those duplicates. So if you have two lines that are exactly the same, it will delete one of those lines. It will delete all the lines until you just have one unique line. Grep is basically search. So you can type in a pattern or a word, and grep will match any lines that have that pattern or that word. WC is word count. It will tell you how many lines of text are in a file or some data stream. It will tell you as well, not just the lines, but how many characters, how many words. It's a very useful tool. And then there's awk. Awk doesn't have a great translation. I think it's just the initials of the authors who created the tool, but it is a useful tool for manipulating data. I have an example here where we're printing out a specific column, and in this case, we're printing out column number 2. There are a lot of different cool things you can do with awk. Awk is basically its own programming language, like its own language of its own, and you can read more about it. Just know that awk is a pretty cool manipulation tool. And oftentimes you might be Googling on how to do things with awk. Another common thing that you can do with awk is basically do a summation. If you have a bunch of numbers on different lines, you could use awk to add up all of those numbers together. Never ask me how to do that. I don't remember the command, but Google is your friend. And if you ask me to do it, I would go and Google it, and you should figure out how to do the same as well. But these are the very high level tools that you'll be using with the command line. I'll run through some specific examples. With cut, you might have this access log from a web server. You can use cut here to specifically get the IP address, right? So you can see there's an IP address in that first column if you're separating all the columns with spaces. And this command will specifically just eliminate all that data and only keep the IP addresses. You could use sort. I've got some numbers here, 502, 500, 100, 340, 200. I do a sort. And it puts them in this order: 100, 200, 340, 500, 502. By default, sort will do a alphabetic sort. In this case, because they were all the same length, each number was all the same length, it turned out that way. There's also numeric sort, which is sort-n. That can help you if you have numbers that are not all the same number of digits. Here's unique. So I've got 2 instances of 500, 3 instances of 100. If I run unique on this file, I'm just left with 100 and 500. An example here with grep. So I'm running the grep command. We are searching for robots.txt inside example.txt. And so you can see example on line 2, we have this robots.txt. If I run this command, it omits line 1 and line 3, and it only gives me line 2. So if you want to search for a specific word and then parse things out on just lines that have a specific word or a pattern, grep uses regular expressions. If you go and search on regular expressions, you can learn more about how to do more sophisticated searching other than just text using regular expressions. I'm going through this very quickly. If you want a more of a primer, you can go look through our YouTube playlist. I cover these much more in depth in our previous log analysis videos. We've got word count here. I've got 3 lines in this file. I run word count on it, and you can see this first 3 indicates the number of lines. The second 3 indicates the number of words, and the second number here, the 36, indicates the number of words, and then the 258 indicates the number of characters in this file. And our final one here is with awk. So I specifically want to get the actual URL that is being requested in this log file. And so I can use awk here to print out column number 7. And that gives me what I'm looking for here with these requests. Now, oftentimes you'll be chaining these commands together to accomplish a larger goal. So for example, you might have you might have a challenge which specifically asks you for figuring out how many IP addresses are in a file, right? So what you might do is use cut to get the column with the IP addresses. Then you might send that to sort, and then you might send that to unique. And then that will tell you how many unique IP addresses are in there. We'll give you a list of all of them, and then you can send that to word count, and then word count will tell you how many lines are in there, and the number of lines is the number of unique IP addresses. And so you can chain these together to do things a little bit more sophisticated. Now, the very, very simple thing that you could do with these command line parsing tools is save them so that you don't have to keep typing the same commands over and over again. And so if you want to build the tool, you can actually, to do log parsing, you can actually take the exact command that you type in on the command line, save it into a file, and then now you can run that file instead of typing out the whole command every single time. So as an example of that here, what I'm showing you how to do is create a bash script. So bash is a command line interpreter. So bash is the program that's actually taking the command line commands that you're typing in and executing them. And you can create a bash script so that you can save all these commands into a single file so you don't have to type them every single time. So this is a very, very simple bash script, and it's just 3 lines. And what you're seeing here at the top, the very first line here is hashtag !bin/bash. Now this specifically lets the interpreter know that this is a bash program, and so interpret these commands that follow as a bash program and not some other programming language like Python or Java or what have you. So, or Java is probably a bad example, like JavaScript. Um, this is the indicator, so the interpreter knows, okay, this is a bash program. The second line here is just a comment, and you can see that the comment says that it takes in a web access log and prints the number of unique IPs. And we're doing kind of what I mentioned here. We are specifically printing out, and this $1 is the argument that you will type after you type in the name of the program. And so it'll take your input and it will use that as the file name, and it'll print out that file, and then it'll send it to cut. It'll grab that first column, it'll unique it, and then it'll give you a word count -l. There's actually a way that this can be improved, which is this program actually assumes that the data is sorted. So you might actually want to go back and add a sort to this, because unique requires the data to be sorted. But this program would basically go and execute on the program that you give it and give you the line count, give you the count for how many unique IP addresses there are. The way that you actually run this is, first you have to run chmod +x to give the file execute permissions. By default, if you create a file, it will not have execute permissions, which means that you cannot run the file as a program. You can only read it as text. And so by doing chmod +x, this will specifically give your program execute permissions so you can run the program. And then my second line here, I am running it, I'm getting the number of IPs, and I'm running it in my examples.txt, and I get the number 1, hypothetically. But the really cool thing here is that if you have written this program to get the number of IPs, and you have multiple different access logs, and they have to be in the same format because otherwise the command might not work, you can consistently get the number of unique IP addresses without having to rewrite that command. So you can write the command once, save it in this file, and run it again, and never have to worry about, how do I write this again in the future? If you are doing one of our competitions, you're doing one of our CTFs, this might be helpful for you, right? You've built this tool for yourself in one CTF. If you have a question like that in the future, you can use the same tool and you can run it again. We might trick you some way with some new variant of a question, or maybe the file is not formatted the same and you have to account for it. But you have a starting point. You can refer back to this code that you already wrote and not have to start back from square one. So this is a very, very simple way to go from scripting, command line scripting, to writing a program to save yourself time and having a record of what you typed without having to learn any programming concepts really whatsoever. You just save it into a file, you can execute it. That's pretty cool and simple. Now, sometimes you might have some challenges with log analysis that are a little bit more sophisticated. And sometimes these command line tools, they're not going to cut it, or they're going to be very cumbersome to use. And you're better served by actually writing some real code. As an example, you might have a question which is asking how, in this example with this access log, how many total bytes were transferred. I can tell you right now that that one of these columns is storing the information for the size of the response that is sent back to the client when it requests a page. And what we need to do here is sum that all up. That seems straightforward enough. But what you might discover is specifically here that, okay, we need this column. In every single line, it's 162, 166, 162, and then 0, right? So we need to get these values. And a very, very trivial way to try to do this is by printing out your log file, using cut to get that column, and then saying, okay, we're gonna cut using space as a delimiter, and then we're gonna get the 10th column. Now the problem is in this last line here, and I think I omitted one of these lines, so there's a mismatch. Yeah, I omitted line 2 in my top example. But what you see in this last line is that because the request is for an empty string, it's not actually a proper HTTP request. It's not a GET request. It's not a POST request. All the other requests here, you see GET space and then an actual URL space, and then you have your protocol, the HTTP/1.1. Now, this last request here is incorrectly formatted. It should be a GET or a POST request, but it's not. And as a result, it doesn't have these spaces in it. And when we specifically try to get the 10th column, this last request doesn't have those extra 2 spaces, which are supposed to be in the request. And as a result, you can see with all the other requests, we actually get a number, but in the final request here, we get this dash, right? Which is not what we want. And it's because it's improperly formatted. And our parsing, our very basic parsing using cut, is failing us here. Now, there are more sophisticated ways that you can chain more command line commands together to solve this problem, to get around it. But let's try to solve this using scripting, through some actual programming. All right. So the programming language that we're going to use right now is JavaScript. You could do this in other programming languages. I've seen a lot of people use Python. You could use Java. You could use Ruby, whatever you want. We're going to use JavaScript today. The reason why is because I've done previous videos explaining how to use JavaScript and how JavaScript coding works. And so, big disclaimer here, if you haven't seen those, you might want to go back and refer to those because it might give you a little bit of a head start here. But just keep in mind that, try to understand the concepts. If the specific things that I'm typing don't make sense to you, try to watch those videos. Maybe they'll help you out a little bit. If that still doesn't help, there's a lot of tutorials online about JavaScript that you can go and watch as well. So a lot of the things I'm trying to teach you here are how to find information that you don't already know. And so if there's something that I'm covering that you don't already know, I'm sure that there are online resources online that can help you figure it out. And I'd highly recommend you go and search those. Don't rely on me to give you exactly everything that you need. All right, so let's write some code. It's demo time. So over here, I've got my Kali machine. I'm going to log in. And while I'm getting set up here, I'm going to remind everyone, please ask any questions that you have in the chat or using the ask a question feature that we have here. I will stop and answer any questions as we go through our demo today. So right now I'm on my Kali machine. I've got 2 windows set up here. The left side we're going to have as our command line. We're going to use this as our reference to looking at the log file that we're parsing. And on the right side is where we're going to have our code. And I'm going to switch back and forth as we go through this process. It's going to be, I'm coding this live, right? This isn't pre-scripted. I'm coding it live with you all here. And so I'm going to walk you through my thought process of exactly what I'm doing as I'm going through the log file and parsing it. So remember, our objective here is we want to figure out, I'm going to go back to my slides. Our objective is to figure out how many total bytes were transferred. All right, that's our goal. So we need to specifically parse out that column properly because when we tried it with the command line, it didn't work so well. So let's see if we can write some code that will make that a little bit easier for ourselves. On the left side here, I've got my command line. I've got my access log here. It's a little bit squished right now because I only have this as a half screen. All right, you can see the access log here. What I'm going to do, because looking at the entire file is a little bit cumbersome, is I'm going to only look at the first 5 lines. I'm going to do head-n5 to only show me the first 5 lines because I don't want to get overwhelmed with everything in this log file. And I can see here what all these requests are. And this is also the wonky request that we know of. The one with just the empty string as the request instead of the whole thing with these spaces inside. You can see here that all these other requests, they have a space, right? They have a get, the HTTP method, they have a space, then the URL, and then another space, and then the protocol. All the other requests here are in this format, but this last request here is blank. It does not have those extra two spaces, which is what's causing us problems when we're trying to access a column which is past this request. All right. So now that we have our objective and we know what the pitfall is that we need to avoid, let's start writing some code. So I'm going to open up my text editor of choice. I'm actually going to use Vim, which is a command line text editor. And you could do this in any text editor of your preference. You could use gedit, you could use Notepad, you can use whatever you want. You probably want to use some sort of programming editor so that you get some syntax highlighting and it helps you out a little bit. But today we're using Vim. And the first thing that we can do is the first thing that we need to do is we need to load in this program into Node.js. So this is something that we did in a past episode. So if like this is not making sense to you, just go back and refer to that past episode. But the first thing is we need to acquire FS. FS is the module that will allow us to do imports of files, load files into our program. So what I need to do is I need to load in, and I'm just going to say, we have this access.log. So I can say, okay, we are going to load in the file and then create an array of all of the lines in that file. And so I'm going to say my array is called lines, and then I'm going to use the fs read file sync function, and that will read access.log. And then I'm going to convert it into a string. So it's text. I just get this instead of getting it as a buffer, I get the data as a string. And then what I'm going to do is I'm going to do split /n. So what this is doing is it is taking in access.log, and it is giving me an array of where every element of that array is a line in this access.log file. What we want to do is we want to iterate through this array. So we want to go through every single line in this lines array and parse out that column with the size of the request. So let's start doing that. I've got, I'm going to create a for loop, which will allow us to iterate through that file. And we need a counter. So we're going to start at 0, and then we're going to go until, actually, I'm going to go to line 5 because we want to start simple. I don't want to get overwhelmed. So what this is a for loop. It will execute 5 times. And what I want to do is I want to take one line at a time and parse out that data. So I'm going to create a new variable called line, which is specifically the one line that we're looking at a time. And it is going to be equal to lines x, like this. What this is doing, it is specifically taking an entry out of the lines array corresponding to the x value. So x starts at 0, and then it goes 0, 1, 2, 3, 4. Because each line, every element in this lines array is a line from the file, and we are getting it sequentially, it's going to read through this list of lines one at a time sequentially, top down. And every time it pulls an element out of that array, it is going to save it into this line variable. And then we can mess with the line variable to extract the data. Okay, so the next thing that we want to do is we want to do a split, another split. So this split up here, it basically took the data and then it, split it based on the /n, which is the new line character. That's what we are splitting on to separate out every single line, right? If you split on new line, everything that you get on the list of items will be just the individual lines there. So let's find something that we can split on that will help us get to the column that we want. So we identified that space, probably not the best way to split. So maybe we split on something else. What I noticed is that in every single one of these lines here, and let me shrink this a little bit so you can see the whole thing. You can see more lines on without wrapping around. You can see here that even though this request doesn't have these extra spaces, it still has these double quotes. And the size of the response happens after the double quotes. So let's split on double quotes. So what I'm going to do is I'm going to do a console.log, and we're going to take the line, and we're going to split on the double quotes. And let's see what happens. So if I come here, shrink this back again, and I type in node myprogram.js, you can see here that it's printing out all of these things. So each one of these double bracket, the open and closed bracket, everything in between is the result for every single line in our file. And you can see here that when we did that, here's the portion that has the IP address and the timestamp. And then here's the portion where it has the request that was made. And here's the portion that has the status code 502, status code 404, status code 400, and then followed by the size of the response. Okay, so what we can see here is that it's consistently, at least with these 5, and definitely if you're doing this to solve a challenge or doing it in real life, you would want to look at more data and verify it in more than just 5 lines. But at least with these 5 lines, it is the case that every single time it's the third element in the array that it contains the text with the size that we want to obtain. So we need to access the third index in this array. Indexes in arrays are 0 indexed, which means you start at index 0 and then you go 1, 2, 3, 4, and 5, right? You don't start counting at 1, you start counting at 0. So if I want to access the 0th element like that, it will print out just this line, as you can see. If I want to access the first element, the second element, I do 1, and you can see here for the first 4 requests, this will give us the actual HTTP request that was made. And for this last one, it gives us a blank because it was blank. And then we type in the 2, and that gives us this information that we want. Okay, now we're still not quite done yet, right? Because we're getting 2 numbers. The first number is the status code of the request, and the second number is the actual size in bytes of the response. So we need to do some manipulation here because we only want that second number. So what I'm going to do first is I'm going to do a trim. And a trim will get rid of this extra, you can see there's an extra space in the front here. I want to get rid of that extra space. So we do a trim, we got rid of that extra space. And now we actually want to do another split. We don't want to split it. We want to split again on this space here. So if I do another split on the space, now it turns each of these lines into two numbers, right? The first one is the status code, and the second one is the size of the response. And because it's an array rather than as a string, so when it was in this step here, this is just text. So the data is not distinguished between this number and the second number, right? Number one and number two are not distinguished. It's all one unit. And what we did with the split on the space is we separated out into two distinct elements. So we can now we can choose to take just the second element. And that is what I'm doing here. I am saying, okay, give me element one, which is the second. And there we go. 162, 136, 166, 162, and 0. Now, it so happens that all of this data is still just text. I want to convert it into a number. And so let me convert it to a number now. And I don't think this will look any different. Oh, the text color changed. So I guess numbers are shown in yellow or orange or whatever this is, orange, I suppose. And then text is just shown as white. And so right now we have response size is equal to this number. I'm just gonna delete this. So we've saved this instead of just printing the number to the screen, we're saving it as a variable. So we can now do something with this. Our original goal was to figure out the total amount of data that was transferred. So we need to keep a tally of that, right? So let's do let, and let's say total bytes transferred equals 0, and I hope I spelled that right. And then what we can do is every single time transferred plus equals response size. So every time we go through a line in the file, we're pulling out the response size. I made a typo here. We're pulling out the response size and we're adding it to our tally. And then at the very end, once we've gone through the whole thing, we can print out the total bytes transferred. And so I'm going to use a format string in JavaScript, and I'm going to say total bytes transferred is total bytes transferred, like that. So let's run it again. If I run it like this, I get total bytes transferred 626. All right, cool. Is that actually correct? Let's actually go and do the math here. Do I have a calculator? Cool, I've got a calculator. So we've got 162 plus 136 plus 166 plus 162 plus 0, right? All right, so those numbers add up. That's a good sign, right? If I actually go and I manually inspect the data again, 162, 162, 136, 166, 162, 0. So does that line up? 166, 162, 166, 162, 136. There's the 136. Okay. I think something might have gotten a little lopped off. 1, 2, 3, 4, 5. 162, 136, 166, 62. Is this correct? What did we print out earlier? 62, 36, 66. 62. All right, that is correct. Cool. So we know that this works on the first five at least. Um, I can now go and say, instead of looking at just the first five lines, we're going to go through the entire file. So let me do lines.length. And now we will run through the entire file. And I'm getting an error. What is the error? Line is not defined. Okay, I made a typo. And now it's saying it can't read trim of undefined. So what is likely happening here is, so it's saying trim is undefined, which means that when we try to split on the double quotes, it's not working. My guess here is that there's probably a blank line that is getting caught up in here, and we're trying to parse it like this. It's giving us an error. So I'm gonna say that if not line, which means basically means if the line is blank, then we're gonna break. We're just gonna exit this loop, so that doesn't cause us any problems. And now we're able to get the total bytes transferred 28,215. I think that number is correct. The only way to go and verify that is just to go through and analyze more of the log and verify that we've accounted for every possible way that the lines are formatted. But we have our answer. We have a starting point here. We just need to go and verify it. But you can see from what we've done with this coding here, you can get a lot more. You can get more a lot more sophisticated, right? Because right now with each line, all we did is we parsed out just how much data was transferred, and then we summed it up. But we could also do something like figure out how much data was transferred to each to each IP address, right? Maybe someone's DDoSing us and they're requesting a web page that has a lot of that's a very large file size. Um, or we want to tally up how many requests were made by each IP address. There's a lot of different possibilities. So this is just a starting point. What I'm going to do right now is I'm going to go through the chat. I'm going to answer some questions, and then I'm going to show you how to do some more of those sophisticated tasks to answer some of those more challenging questions. So let's take a look at chat. All right, we've got people asking, Tom's asking, any specific method, process, procedure for chain of custody? That's a little bit out of scope for our conversation today in terms of like if you're looking at that first from a like a law enforcement perspective in terms of chain of custody. If you are doing this kind of not in a law enforcement context, but in a just general operational context, um, best like the very easy pro tip is to always keep an original copy, right? Don't edit the only copy that you have. Make a copy of it and then mess with the copy. Don't mess with the original. And if you're doing this from like from in a CTF where you can re-download the file, that's not too bad. But if you're doing this operationally within an organization, I'd even have copies on multiple different devices, right? So have a copy on a different computer or cloud backup or what have you, so that if something goes wrong with your device, you don't lose the only copy that you have. Um, got a question here. Why don't you just import this into a SQL database and then use select statements? You could, but then the question becomes, how do you import it into a SQL database? You're not going to always be able to, like, did someone write a program that will take in this file to import it into a SQL database? Or are you going to have to write that program to import into a SQL database? I like one of the two things that's going to have to happen. If there happens to be a tool readily available on the internet that allows you to import into a SQL database, then that's a great way to solve this challenge as well. I've seen people get very creative with the ways that they solve these log analysis challenges. Um, okay. And I've got, and Jason is asking, do you want to use break or continue in that loop? In this case, either one works. I guess in general, continue might work better. So break specifically exits the loop. Continue basically skips the remainder of the commands for this iteration and then moves on to the next iteration. I happen to know that if you're going to have like an extra empty space at the end, it's going to empty space in sorry. If you happen to have a line that is empty, it's going to be at the end. So you can use a break because we're already at the end of the file. So in this context, it doesn't matter. But I think in general, if you might have random empty lines inside the file, you might want to use continue instead of break. Albert's asking, is there any specific reason to use JavaScript versus Python? It's personal preference. And on top of that, the only other difference is that people might have written existing code libraries that you can import. And if there's something that you want to do where someone has written that in JavaScript versus in Python, then you might choose the language that has the code that's already pre-written for you. But in general, they will accomplish the same things. It's more of a personal preference. We've got a question: which website or YouTube video can you recommend to learn JavaScript? There's a lot of different resources out there. I recommend. I've had. I've personally taken the Code School. I think now it's plural site. Intro to JavaScript or Node.js video series that they have. I found that to be pretty helpful. Um, that's the one that I've personally used. I'm sure there's a lot of people, like a lot of different ones that people might be able to recommend. But I see Jason has recommended Code Academy. That's also a pretty good resource as well. I think they might have some free courses that you can use to learn JavaScript. And Robert's asking, is there any benefit to using Elasticsearch versus Cabana? So Elasticsearch and Cabana basically allow you to run queries instead of writing code. So it's much quicker for you um, to like actually do some analysis. It's a different skill set. I think for the types of questions that we're asking today, Elasticsearch and Cabana could be a better tool in terms of time efficiency. If you're someone who knows how to code, but you don't know how to use Elasticsearch or Cabana, it might be faster for you to write code to do it versus learning how to use Elasticsearch or Cabana. It's all about kind of like your like you need to have the right tool for the task. If if you don't know how to code but you know how to use Elasticsearch and Cabana, then that might be the way to go. You might also have a situation where you've got a really really big file and you writing a code to do it in JavaScript is too slow, and doing it in Elasticsearch is going to be faster. Then you probably want to use Elasticsearch. It really depends on the context, but I'd say in general, most of the challenges that we have, you can solve using Elasticsearch or Cabana, unless it's not a standardized log format. Like the previous question we had about why don't you just import this into a SQL database and run SQL queries? Why don't you just import it into Elasticsearch and Cabana? I know for a fact that there are parsers with Elasticsearch and Cabana where you can import an HTTP access log into Elasticsearch, but we've done challenges in the past where it's a custom log format which you cannot automatically import into Elasticsearch. And so your options would be to write your own parser for Elasticsearch or to code your own program to parse out the log file. So you need to choose the right tool for the task. For any of these well-defined log files, Elasticsearch might very well be the most efficient way of doing it. But yeah, just keep in mind the context that you're experiencing. All right. So that kind of sums up all the questions that we got in so far. I'm going to take a swing at solving a more complicated challenge. So right now we just summed up the total bytes that were transferred. I'm going to tweak this and I'm going to say, let's try to figure out how many bytes were transferred to each IP address. And I guess I should probably preface this a little bit by saying it's not how many total bytes were transferred um, at the network layer, it's how many bytes were transferred in response to these HTTP requests that we're getting at the application layer. So if we want to figure out and associate the data to IP addresses, we need to collect the IP addresses from each line, not just the response sizes, but also the IP addresses. So let's go and do that right now. So we are collecting response sizes. We need to collect an IP address. And I happen to know that when we tried parsing this out with the command line, that doing it with the spaces as the delimiters worked pretty well. So let's do that again. Let's do a line.split on space. And let's see how this looks. And I'm going to comment out this last line for now while we play around. Okay, we got an error. I think I made a typo somewhere. Response size. I added by accident an extra slash over here. Okay, so you can see here the first element is an IP address. IP address there, IP address there. I'm going to go back and I'm going to say just look at the first 5 lines again so we don't get this huge list of data. Okay, so IP address is the first element, IP address is the first element, IP address is the first element. All right. So what I just did was I just was saying, well, we got this list here every single time the IP address was the first element, so let's just pull out index 0, and there you have it. Every single IP address in the first 5 lines is what we parsed out. So now we have the response size and we have the IP address. What we want to do now is create in JavaScript what is called an object, or in some other languages it's called a dictionary, but it's effectively a key value store. So you have you can store data and reference that data by a string. So I'm going to call this IPs, and the curly brackets are how we declare this object. And what we're going to need to do is write some logic and say, hey, if we've already seen this IP address, we can make a modification and add the number of bytes that we're seeing to that IP address. And if it's not already in there, then we need to make an entry in this object so that we can keep track of it. So I need to see if IPs has this IP address, then we'll need to increment the running total. And if it's not in there, we need to make an entry in the IP's object to keep tracking it. So if it already exists, then what we can do is plus equals response size. So if we already have a tally of the number of bytes from that IP address, we're just going to increment it. But if we don't, we need to create a new entry for it, and we're going to make the current tally the existing response size that we have. Cool. So we're no longer using this total bytes transferred. I guess we could keep it in here for posterity. Um, and the first thing I'm going to do is I'm going to run this, make sure it doesn't give me an error. Aha, it gave me an error. Response size is not defined. I made a typo. Response size. All right, let's try it again. Cool. So no error this time. And then at the very end, we can print out all of the IPs like that. And you can see here there's 4 IP addresses, and here's how many bytes each of them processed. Each of them had were sent in these responses. Let's verify that, right? So I think, yeah, this is kind of ugly. I'm gonna assume that we parse out the response size and the IPs correctly. So I'm just gonna print them out. IP response size, like that. And I'm gonna comment this out. All right, I'll leave it there. All right, let's run it. So this IP, this IP, this IP, this IP. So it turns out each of these IPs, the first four were unique. This second request from the same IP address ended up being size 0. So it didn't, it when you add 0 to a number, it doesn't change it. So all of this information is correct, but let's see if we can actually add a non-zero value to the total. And instead of doing the first 5 lines, I'll do the first 8. Let's get a little bit more data in here. Still doesn't quite help us. I think these are all still. How far am I going to have to go before I get a duplicate? Ah, okay, there we go. We got a duplicate. So this dot 241 appears twice in here, and it's transferring 867 bytes. So where's our nifty calculator? 867 plus 867, 1734. And if you go and you look up this entry in here, it's 1734. Perfect. The numbers add up. So we know it works. So now instead of doing the first 10 lines, I can go and do lines.size, and we can get the full number. But that didn't work for some reason. All right, what am I doing wrong? Let's try to figure this out. Oh, it's because it's not dot size. It's supposed to be dot length. I'm going crazy. Okay, there we go. Here are all the IP addresses and how much data was transferred to each one of them. That's pretty cool, right? And I can eyeball this and I can see this IP address transferred the most. This was like 4,600, and everything else here looks below 4,600. But I mean, we can keep going and getting more sophisticated with this, right? I mean, from here, you can, you can figure out, um, you can calculate standard deviation, and you can figure out, okay, is there an IP address that's like requesting way more data than all the other IP addresses? We looked at data, but you can make these requests. Is someone DDoSing us? Is someone sending us abnormally more requests than most people? This is all type. These are all just analytics that you're calculating within the log file. Now, I think as some people have mentioned in their questions, there are a lot of other tools. There are specifically log analysis tools like Splunk or Elastic, or you could even use SQL. There are a lot of different tools out there that can help you understand how to do the log analysis. But I think it's pretty important to understand a lot of these fundamental concepts, right? Of, how are we, the concept of like parsing through the file and understanding what's happening when you're analyzing it. And being able to do this yourself is pretty powerful because sometimes a tool might not work, and writing a script might be a faster way of accomplishing your goal, or a very quick program. So hopefully this was helpful to a lot of you watching. That kind of concludes all of my demo and my slides here, but I'll stick around and answer any final questions that people have. Before I go, I'm going to put up a poll. Please let us know, uh, what topics you want us to cover in the future. I always kind of gear my future episodes based on what people say. And if you haven't already, we're currently in the middle of registration for NCL. There's a button up here on the live stream. You can click on that button. It'll get you registered. If you register for NCL right now, you can actually go in the practice gym and you can try looking at this access log for yourself. There's this access log in the practice gym. You can see if you can write some code to analyze and parse it yourself. And if you've got any questions about that, you can come back to the YouTube channel and ask questions in the comments. But it doesn't look like we've got any further questions for today's episode. So thanks once again for everyone joining us today. Give us some feedback in the poll. What do you want us to cover? If there's something that you want us to cover that isn't in the poll, ask about it in the chat, and we'll be back with more episodes next week. So thanks once again. Take care, everyone. Good luck in the National Cyber League if you're competing. But yeah, take care.